shit, I forgot to look at the website. Sports, athletics. Dumbbell. Concentration curl. Here, I'll show you what I'm looking at. Okay, that gets pulled from this, which I didn't realize before. Okay. So, concentration curl. 10 pounds, 100 times. Let's see if I can break my record. That's the one. What the hell? It's the wrong link. What the fuck? Alright, whatever. Forgot to put on my book.
Represents 1 and down represents 0.
So we'll break my concentration curl record.
Can be controlled by applying a magnetic field briefly.
110.
Causes the magnet to rotate to a different orientation. This activates the quantum QR gate operation needed as part of the quantum computer operation described earlier. To create a quantum computer, many phosphorus atoms are needed for representing many qubits, and Q-XOR gate operations involving pairs of qubits need to be carried out. The many phosphorus atoms are arranged in a pattern like a chessboard, with a phosphorus atom at the center of each square, which has dimensions of 30 nanometers by 30 nanometers. Remember, the size of a single atom is about 0.2 nanometer, so these are very small squares. Normally, the qubits stored in the internal magnetic orientations of each phosphorus atom do not affect one another. This is quiet time, when the qubit values are simply being stored. The entire silicon crystal must be cooled to an extremely low temperature, negative 391 degrees Fahrenheit, or negative 196 degrees Celsius. This prevents the internal magnets from being buffeted by excessive jiggling of the silicon atoms making up the crystal, which could lead to the nucleus's magnets being rotated accidentally into the wrong orientations. As we discussed earlier, this would lead to errors in the states of the qubits and require that error correction methods be used. If researchers want to perform a Q-XOR gate operation between two neighboring phosphorus atoms, they activate each by passing one electron from nearby wires into each of the atoms. For reasons
50, that's
having
all I
to
can
with
do.
quantum physics, the internal magnet
50 per side, 10
becomes
pounders.
much stronger, and they begin to affect one another. If you've ever held two magnets close to each other, you know the stronger one tends to push and rotate the other one. The arrangement of the two phosphorus atoms leads to the Q-XOR operation as follows. The magnet in one of the phosphorus atoms, called qubit B, controls what happens to the magnet in the other phosphorus atom, called qubit A. That is, if B equals 0, magnet down, then qubit A remains unchanged. However, if B equals 1, magnet up, then qubit A's magnet is pushed and gets flipped from 0 to 1, down to up, or from 1 to 0, up to down. The researchers can carry out a sequence of Q-XOR gate operations involving different neighboring pairs, interspersed with QR operations of any single qubit. Therefore, in principle at least, they have constructed all the needed components for a scalable quantum computer. The great thing about this work and architecture is that it gives us an endpoint, says Professor Michelle Simmons, director of the University of New South Wales project. We now know exactly what we need to do in the international race to get there. Chapter 11. Energy quantization and atoms.
Oh my god.
What is energy?
That's all I can do.
quantization?
50 per side. So
We
now,
now
whenever I
recover
do
historical progression and
weightlifting,
discuss
because
Schrödinger's
I get tired
equation,
easily because I'm out of
describes
shape,
the properties and
I'll
behavior
do a set of
of
weightlifting and then I'll
That's
do
what Schrödinger's
3 minutes of
original
stretching my
This area of
hamstrings
discussion
because
is
that
called
is
quantum
very,
mechanics.
very important.
A major idea
For me,
of mechanics is that
stretch
under
my
certain
hammies.
conditions, energy is quantized. Quantized means discrete. That is, existing only at particular separated values. A classical example is the discrete levels of a staircase,
We're gonna do-
as opposed to the continuous
we're going to do a
smoothness
minute
of
and a half
ring.
per side.
On a staircase, you can stand only at certain discrete heights. In contrast, on a ramp, you can stand at any height. In that case, the height varies continuously, rather than being quantized. Quantization means limiting the possible values of a quantity to a discrete set of possible values. For example, replacing a ramp by a staircase would be a quantization of the height. In certain situations, energy is quantized. Why is energy quantized when a particle is confined? For a quantum particle moving freely through space, its range of possible energy values is continuous. Any value is possible. Energy is not quantized. In contrast, for a quantum particle confined to a small enough region, its energy is quantized. Only certain discrete values are possible. The possible values depend on the size and shape of the region in which the particle is confined. It is found that the smaller the region, the stronger the quantization effect, in that the allowed energy values are more separated. The energy steps are larger, and it takes more energy to go from one level to the next. Why is energy quantized when a quantum particle is confined? The answer is given by Schrödinger's equation, which represents the behavior of the possibility wave, or psi wave, associated with an electron, as discussed in Chapter 6. An electron is confined, bounded by the rigid walls off which the electrons bounce or reflect. Imagine the setup is in the International Space Station, so the effects of gravity can be ignored for the most part. And assume there is no friction, so once set in motion, the electron would bounce forever. The electron moves freely, except when it encounters a wall. Therefore, all of its energy is energy of motion, and there is no
Need my
stored energy.
straps.
In classical physics, we would use Newton's equation to predict the trajectory of the particle, which would determine its position and velocity at future times. In quantum physics, there is no concept of trajectory, only a psi wave description. The psi wave must equal 0 at the walls and beyond the walls, consistent with the fact that the probability to observe the electron at these has 5 complete.
I need to remember to drink a lot of water too.
Because
a
according
lot
to
of water.
Schrödinger's equation, the curviness of
Like
the
have
psi
it
wave
available constantly.
designates
I'm gonna go
particles'
get it
energy
now.
of motion 5 complete oscillations correspond to a
After
particular.
this stretching, I'm gonna go get it.
The second psi wave has 5 1/2 oscillations corresponding to a different possible energy. The third psi wave has 6 complete oscillations, giving yet another possible energy.
Oh,
Notice that, for
All right.
example, 5
go
and
get some
1/4
water.
oscillations would not
I'll be right
fit
back.
nicely between the walls
Oh.
because the psi wave value would
Forgot
not
to
be
bring it
0
this
at
time.
both walls, as it must be. The psi wave will equal 0 at the walls only if the number of oscillations equals an integer, 1, 2, 3, and so on, or a half integer, 1.5, 2.5, 3.5, and so on. As mentioned, Schrodinger's equation tells us energy of motion is represented by the curviness of the psi wave. So if the number of oscillations is held to certain discrete values, then the energy is also held to certain discrete values. This is energy quantization. Schrodinger's equation says, for a particle confined to a region, the particle's possible energies must be quantized. Now we can understand why energy is not quantized for a particle that is not confined. It can have any energy because there is no restriction on how many oscillations there could be in any particular region. So the collection of possible energies is continuous in this case. Of course, for a particle that is described properly by classical physics, there is no direct
Okay.
counterpart to this behavior. A table tennis ball
So I'm
bounces
gonna
back and forth between two walls
Find my
can
video.
have any amount of energy in a continuous range. Its energy is not quantized.
This
Any
would be the
quantum effects
north.
in such cases are
Oh no,
permanent
north
effects
disappeared.
The object is interacting with its surroundings. You can hear it bounce,
no.
and thus is constantly
I thought it
leaving
was the
behind traces
cable.
of where it has been. It's not a unitary quantum process,
Oh,
and thus
shit.
quantum effects are observable.
Fuck. The north
How is the
camera, it
energy
just,
of an electron in an atom quantized?
you only get a little
The
bit of
answer
time
is
out of
again
it.
embodied in Schrodinger's equation, which asserts the following. 1. An electron in an atom moves in a way that depends on its energy of motion
Oh, I
and its
know.
stored energy at each location.
I'm gonna,
2. The energy of motion is determined
I'm
by the
gonna
curviness
unplug
of
it
the
and then
psi
plug it
wave
again.
representing the electron. And 3.
Oh
The
my
amount of stored
God,
energy
this
depends on the electron's location.
hardware, dude.
Consider an electron in, say, a sodium atom, which gives the orange glow to some street lamps. An energy valley is created by the attraction the electron feels toward the positively charged nucleus at the center of the atom. The electron is
You need to
pulled
paint these.
by electrical attraction toward the center, as if rolling down a valley side. The stored energy at each distance from the atom's center can be plotted as a gray curve. If the electron were at the very bottom of the valley, its stored energy would be 0. It couldn't go
This
any
one is the
lower.
close one.
At the other extreme, if the electron's energy of motion were to exceed 5.27
This
energy
one.
units, it would fly out and leave the valley. Otherwise, it is
Okay,
trapped,
this is the north one.
confined
Damn.
within the atom's volume.
What is going on here?
Because the electron is confined to a region, we expect the electron's energy to be quantized. In every case, the psi wave
Oh,
must
no.
equal 0, far from the atom's
Oh,
center,
fuck.
at which locations the electron
they're all
has 0
missing.
chance to be observed. And
Oh,
in general,
fuck.
as the allowed energy is increased,
What?
the psi wave has more oscillations.